Hello everyone. We are beginning with our study of physical geography from today, and as we have taken the understanding of the question paper discussions in the earlier videos, we are basically dividing the content matter into three sections, and these three sections will be: number one, the study of landform features, that is technically called geomorphology. Number two, the weather mechanism, which incorporate climatic conditions also, we technically call it climatology. And the third section that is covered up in this physical section, for which we'll be getting our first test on 12th of January, will be the study of hydrosphere, that is largely related to the surface water, specifically the study that is correlated to the oceans and their marginal water bodies, as well as the groundwater and also the river systems. So when we try to divide these three parts and try to see what type of questions have been asked in examination, as I said in the earlier videos also, whenever you have reached the lowest level, there is no other way but to get up. So that goes very relevant with what we say as physical geography questions. So when I say physical geography, the number of questions that have been there in the prelims examination in past few years, the number has tremendously decreased. And because the number has decreased, we very sincerely believe that the number is now going to increase. So when you try to apply the understanding very clearly of all these content matter, it gives me the support to interpret how to go about with its preparation. The nature of questions that we encounter from these topics is largely related to Ncert, Go Chi Leong, and also when I take reference of the study of these, it very clearly orients towards the interpretation of what is the content matter of these topics. Now when we take the part 1, which we are focusing today, it very clearly gives me the understanding of one point. And what is that one point? Physical geography as processes called endogenetic and exogenetic is very well covered and discussed. What is the part that goes slightly in hiding is what is relief forming material, and that is what I want to take this particular video oriented towards altogether. And if we try to justify the approach of preparation for that prelims oriented study, it always will be related, it will always be helpful actually for me to understand what is the way. Content is available everywhere. I pick up one textbook, I pick up other textbook, I get all the material, but how to go about with retaining that content matter. So we are focusing this particular point first with the study of what are minerals and the different types of rocks, taking support of both Ncert content as well as some very basic creative flowcharts that helps us to comprehend this particular part easily. So without wasting any time, let us get going with the understanding of first part in the study of geomorphology in geography. Rocks and rock forming minerals. Okay, let's begin with our first study. I have opened up in front of you page number 40 of Ncert, Physical Geography 11th class Ncert. It is all about the minerals and rocks which are considered to be building material. When I say building material of relief feature, it basically gives me the understanding that I am talking about rocks that forms the earth's crust, rocks that forms the relief features of the earth's crust. What exactly I need to derive out from this particular chapter of Ncert? So if I have to take the specification of this chapter, the first thing that I need to be aware of, and that is something very important, is what are the major elements of the earth's crust. So the first thing that you should focus on very clearly is that when we pick up the composition of earth, I have got what decreasing order, like oxygen, silica, aluminium, iron makes the four principal constituents that makes the earth's crust. And we have encountered questions that have been directly asked from this. And I also can have that which of the following, say number 5 to number 8, that examiner gives me calcium, sodium, potassium and magnesium and ask me to understand or highlight which of them is correct in the ascending or descending order. So basically I need to be aware of these constituents clearly in terms of our understanding. So if you try to correlate this with the content matter of your complete syllabus, I am talking about the building material of lithospheric stratas, and it goes very prominently with 8 elements, and if I have to highlight it, very important, about 98% of Earth's total crust is composed of 8 elements, and I have already highlighted them. Club them into 4+4 category: oxygen, silicon, aluminium, iron versus calcium, sodium, potassium and magnesium. These 8 accounts for 98%. So I am precisely done with all. And if you try to take this reference of study with the combination of, right, if that tabular representation is converted into this pie chart, it becomes more visually appealing for me to understand how to go about with its constituents. So as we have learned, there are 4 major constituents that accounts for there are 8, we have divided them into major and minor. So if I see it from here, it is oxygen number 1, it is silica number 2, it is aluminium and it is iron. And I can easily see with this visually appealing fact, oxygen accounting for 47%. So major most share comes up with it, followed on by silica, that is accounting for some 28% of the total constituents. And if I continue with the list, I can easily notice it is aluminium, and followed on by it is iron. Once I have taken this, a point question becomes very easy for me to handle, and just remind yourself, we very clearly picked up the categories which goes as minor: calcium, sodium, potassium, magnesium. First part hence is done. 98% of the Earth's building material is 8 elements, namely oxygen, silica, aluminium, iron, calcium, sodium, potassium and magnesium in decreasing order of significance. If we take second step in the continuity, so if I pick up the second constituent that goes up with our chapter on minerals and rocks of Ncert, it asks me to be aware of the physical characteristics, very clear physical characteristics of minerals. So which are the physical characteristics of mineral? A brief detail is being available in Ncert and I need to be aware of them specifically. So external crystal form, cleavage, fracture and lustre. These are the 4 major constituents of physical characteristics of minerals, followed on by color, streak. Try to see on lustre, color and streak can be combined together. Transparency, structure, hardness and specific gravity. When I say what are the 10 constituents of physical characteristics of minerals, we normally very easily talk about color, we normally very easily take into reference streak and transparency. When I say color, streak and transparency, lustre, the nature and the magnitude of reflectance comes up in its account. Cleavage makes very interesting constituent which can be related to fracture, as in these are correlated very strongly with the physical appearance of the minerals that forms the rock. If we take this table in terms of brief details which has been availed in Ncert, before getting to the details of this hardness, we will be getting much clear reference of what I am trying to emphasize in our study of this particular block. So let us quickly get to the page of Ncert. Right, can we notice it's a clear table that is being given to us on the very first page of this chapter that talks about brief details, like we have emphasized already that when I take reference very clearly of physical characteristics of minerals. So what are the physical characteristics that I take? External crystal form determined by the internal arrangement of the molecules. Crystal forms are determined by internal arrangement of the molecules. What is meant by cleavage? Cleavage is the tendency to break in given direction, producing relatively plane surfaces. These are very important constituents that we take with the physical properties. If I continue with the list, then I have the other 8 constituents given in the subsequent page. And if I continue to pick them up, what are the constituents that are being given? Fracture. It is internal molecular arrangement. Luster. It is appearance of the material without the regard of the color. That some minerals have got characteristics, color determined by their molecular structure. And if we continue with the list altogether, what are the constituents that we are getting? Number 6, 7 and 8 is visible here for us to handle. So let us go with 6. We have already seen streak, transparency. I said that we should correlate them very clearly with the color, because color will be determining ground powder of any material. Like when we try to, example is being given, malachite is green and gives green streak. Fluoride is purple or green but it gives white streak. Like we have been noticing how the goldsmith, by rubbing gold on a harder surface, tends to give us the understanding, okay, this is pure gold or not pure gold. That kind of point we are taking here. Following that, we pick up the category of structure. I am just jumping across structure, particular arrangement of individual crystals, fine, medium or coarse grain. Hardness is what I am jumping across to get into specific gravity. And what is meant by specific gravity? Our NCERT gives us excellent description. Actually, we should not go beyond it. Question can easily be framed up from that. Specific gravity is the ratio between the weight of a given object and the weight of equal volume of water. If you try to take this and apply, which are the constituents that we see when it comes to the reference very clearly of physical characteristics of minerals. So physical characteristics of minerals incorporate external cleavage, fracture, luster, color, streak, transparency, structure, hardness and specific gravity. And anything that will go beyond this level of study will be by default. List is given in your NCERT, but if you try to take that list and apply it here, which is the scale on which we measure the hardness of the physical property of minerals. So it's called Mohs hardness scale. And we have got 10 rating applicable to it. Talc makes the softest, rating is 1 and it is softest known minerals. Gypsum, calcite, fluoride follows in the sequence. And what is to be noticed is diamond. Diamond represents 10 on the hardness score, and because it is 10 on the hardness score, it is hardest known minerals. So when I say 2 steps in the first 2 pages of NCERT to be taken into account, what we have added, that when we learn the 2 pages of minerals and their constituents, we have to understand and remind 98% of Earth's crust is formed up of just 8 minerals, and that minerals are dominantly characterized with their 10-point physical characteristics. One of the dominant physical characteristics or properties of minerals is considered to be hardness, and that is measured and studied by Mohs hardness scale. What is the range of Mohs hardness scale? It is 1 to 10. Point that you have to notice is that every time I am somewhere repeating these constituents, I am giving myself the understanding of this is the way I'll prepare. So I have learned 98% with 8 minerals. I have learned that all the 8 minerals are identified with 10-fold or 10 types of physical characteristics. One of the 10 type is hardness, and hardness of the minerals is studied on, we have taken this and we are applying it again, is studied on the basis of Mohs hardness scale, and this scale divides the hardness rating. It is about rating, hardness rating from 1 to 10, 1 being softest known, 10 being hardest known. And this is how I can easily demarcate the content matter of this particular chapter, part 1. And as we proceed to the next, now these are factual things, agreed. And these factual things are done when you try to justify them in a logical sequence of learning. So I take the next page in our study to pick up the types of rocks. Right, so 3 types of rocks that we very clearly believe in, and not a difficult part altogether. Categories are important and we need to be aware of it. So igneous rocks that are formed out of magma and lava from Earth's interiors. These 2 terms can be further distinguished. When I say magma, I actually correlate it with chamber. And when I say lava, when I'm talking about outflow. Both of them basically correlate with molten rock material, but they are different from each other. When the magma is in its upward movement, cools and turns into solid form, it is called igneous rock. Igneous rocks are classified on the basis of texture. Igneous rocks are also classified on the basis of texture based category is what is emphasized in Ncert, and I'll just be creating the flowchart to make you understand that apart from texture, we also classify igneous rock on the basis of their composition, as well as on the basis of their location. Based on composition, we identify different types of igneous rocks, like here in the physical geography Ncert says, based on texture, we have got the different arrangement of grain. So if the molten material cools very slowly at greater depth, see location is mentioned, mineral grain becomes very large, and sudden cooling creates smaller or intermediate grain. How do we take the distinction between the two? Now let us try to notice it with reference to this. Right, can we notice that when I take the demarcation of igneous rocks precisely in the categories that are demarcated on the basis of their different types of compositional constituents. Right, if I have to enlarge it from what we have seen in Ncert, igneous rocks are classified on the basis of texture. But actually we can classify igneous rocks on the basis at least of 3 things. Which are they? I can classify igneous rock on the basis of their texture, picking it up from absolutely Ncert. I can also classify it on the basis of its composition. And also on the basis of their location. Now what you need to understand is that when I take the texture of igneous rock, it basically is determined by rate of cooling. So when I say the texture is determined by rate of cooling, and rate of cooling will be determined by both the composition of magma as well as location. So on the basis of location we have got extrusive and intrusive category. And if I have to pick up the categories that goes with composition and etc., I'm creating table one by one. So texture based category, I distinguish between based on composition, I essentially distinguish between what is meant by a phenetic texture. Aphenetic stands for invisible. As in, I am very fine textured igneous rock. Visible. Without any support of instruments, I can see the crystals that are present in igneous rock. So those big crystals, igneous rock, where crystals will be visible, texture is visible without the support of any tool or instrument, will be pheneritic, visible. And if it is very fine textured, it will be without any instrument, I cannot note that texture, it will be aphenetic. Aphenetic rate of cooling has to be faster, in sense that if I am cooling faster, then only I will be developing smaller texture. And what will determine that I am cooling faster, if I have to compare them, which will be the location where I will cool faster? By default extrusive, because once magma is ejected out, then it will be subjected to much swifter cooling compared to magma which is getting solidified within the Earth's interior. But is this the sufficient combination for me to study? No, I can have also composition-based demarcation. Geologically, we believe in actually four types of composition of magma: felsic, intermediate, mafic, and ultramafic. When I take the general categorization of igneous rocks in terms of their composition, we believe in two, which are felsic rocks, which are rich in silica. They have got more than 60-65% of silica. And what will be mafic rock? That has got less than 40-45% of silica. Silica tends to determine viscosity of magma, thus its rate of cooling. Please apply. I have got igneous rock which can be classified on the basis of their texture, that is dependent on composition and location. Standard rule: if I am felsic igneous rock, par excellent felsic igneous rock is granite. If I am felsic igneous rock, higher amount of silica will make me viscous. Because of viscosity, I'll be cooling faster. And because I'll cool faster, I'll be developing a phenetic texture. Felsic igneous rocks are essentially a phenetic textured. Mafic igneous rock, basalt, is essentially pheneritic texture. But will that be an absolute category? No. Granite and basalt can develop in extrusive and intrusive location also. With the support of such type of categorization, things becomes much more easier when it comes to the understanding and enlargement of rock types. So I repeat, and I can also easily write down, because if I have to make sense with which are the prominent types of igneous rocks, if I have to make the names of igneous rock, I'll say felsic category is best represented, as I have already said, granite and also diorite. And mafic category is best represented by basalt as well as peridotite. Suffices. Because just that small paragraph in Ncert is not giving me the defined set of information that I need to be aware of for igneous rock. So once you take this kind of revision, it becomes very easy. Your preparation becomes precisely foolproof. Before I go further, I divide igneous rock essentially on the basis of their texture and composition. Texture is determined by rate of cooling. Rate of cooling is determined by the composition of magma and the location where magma will be subjected to cooling. The next rock that can be seen is sedimentary rock, and sedimentary rock without any doubt is correlated with the cooling sedimentation. So I pick up this term from our Ncert. Sedimentary is derived from Latin term that stands for settling. That when the denudational agents results in the breaking up of the rocks and creating what is called broken rock material or sediments, and their deposition cementation will result into the development of sedimentary rocks. So depending on the mode of formation, sedimentary rocks are classified as mechanically formed, organically formed, and also chemically formed. If I pick up Ncert, I get all the three categories very well defined. And if I try to overlap it with the content matter flow chart, then it will be like this. Right, if I have to take sedimentary rock also in the same kind of easing out the burden, enlarging the required details which is not there in our Ncert for our upcoming prelims examination, I can again swiftly take support of a flow chart. Sedimentary rocks, elementary sediments, lithification, diagenesis, cementation, compaction, aware of. Sedimentary rocks are fundamentally classified on the basis of their texture as well as on the basis of their composition. When I take these two categories, I have a technical set of terminology that I can easily apply. And what are these technical set of terminology that I can apply? Texture means clastic or detrital. Sedimentary rocks. I'll come to it in a while. Texture of deposited sediments. I don't need to write the names here. Mudstone, siltstone, sandstone. What is argillaceous texture? Finer texture, finest texture, clastic sediments that leads to the development of argillaceous clastic sedimentary rock. So how many, very common type, how many types of sedimentary rocks we can distinguish? We can distinguish argillaceous, arenaceous and rudaceous categories of sedimentary rock. What is the basis on which we categorize them? It's based on texture. Because when I say mechanically formed, as written in our Ncert, so mechanically formed means I am talking about texture. And what are the technical categories for this? These are 1, 2 and 3. And how many types of sedimentary rocks within these three categories can be commonly recognized? So I've got shale, I've got mudstone, they belong to argillaceous. I have got siltstone, sandstone, that belongs to arenaceous. I have got conglomerates, that belongs to rudaceous, and almost all the names are mentioned in our NCERT. So I classify sedimentary rocks based on their texture, and based on their texture, what is the category that is being applied? It is called clastic sedimentary rock. So based on composition, which type of sedimentary rocks we are talking about? Non-clastic. And if I have to fit in with the terms mentioned in our NCERT, then it comes out to be which categories? Mechanically is texture, so chemically and organically formed will be here. So we call them non-plastic or non-detrital, and the categories that we can apply is become easier, because if I say carbonaceous, I am more talking about organically formed. Peat, lignite, bituminous, anthracite are which type of sedimentary rocks? They are carbonaceous, non-clastic sedimentary rock. Calcareous, limestone and dolomite. And if I have to talk about siliceous, I'll say it is chalk, gypsum. Sedimentary rocks are classified on the basis of two. NCERT says three, let it be three. On the basis of texture and on the basis of composition. When I say on the basis of texture, I have got three types. And when I say on the basis of composition, I can count three as I have created the flow chart, or I'll go very religiously with NCERT and say, no, it is two subdivide. One is organically formed, so carbonaceous, and one is chemically formed, so calcareous and siliceous. That is how you can take the reference of their categorization. Sedimentary rocks includes two basic categories of divide. The final type of rock, metamorphic rock. The word metamorphic means change of form, and these rocks are formed under the action of pressure, volume and temperature, PVT. Metamorphic rocks are very strongly identified as metamorphism, the process by which already consolidated rock undergoes recrystallization and reorganization of material within the original rock. This is how I distinguish between metamorphic rock and other rocks. NCERT continues to give me the categories that I can correlate with metamorphism. So metamorphism can be identified with two types. There are two types: thermal metamorphism, which is correlated with temperature change, and thermal metamorphism can be contact and regional metamorphism. When I take that mechanical disruption and reorganization of original minerals due to breaking and crushing without any applicable chemical changes, that is dynamic metamorphism. So dynamic metamorphism and thermal metamorphism 1 and 2 are the types of metamorphic processes that we correlate, and this results in how many types of metamorphic rock which we need to understand with the support of flowchart. So what my NCERT is giving me, it is giving me the process by which metamorphism is taking place, and also how many types of metamorphism are there. So I divide metamorphic activities into two, and which are they? I am just removing all the other constituents. One type of metamorphism that I am noticing is dynamic, and two type is thermal. This is how I take the distinction between the two. And how do I go about with the enlargement or the categorization of them? It will be with the support of this flowchart. The third and the final type of rock, called metamorphic rock, interestingly is classified only on the basis of its texture, and the categories that are distinguished are called foliated and non-foliated. What is meant by foliated category of metamorphic rock? If I write one name, it will be more easier for you to understand. Think about marble. We all talk about marble and marble flooring and etc. Why it is so that marble flooring goes with variable texture. Some of them have got well-defined cleavages, some of them do not have. If the cracks in the marble will be larger or higher, more visible, then its value goes decreased, otherwise it will be of high value. That means a given type of marble may not have. Please recall the elements, the minerals characteristics that we talked about in this lecture. So when I say the planar element is unclear, that every developed marble will have a different type of texture. We call them non-foliated. Is marble the only example of non-foliated metamorphic rock? No, I can also include quartzite. Marble is essentially a metamorphized form of limestone, and quartzite is essentially the metamorphized form of sandstone. But when I say that the metamorphic rock has got foliated characteristics, then what characteristics we apply? Clear planar element, as in they will have repetitive. Every example of gneiss, every example of slate will incorporate clear planar element, and that clear planar element makes them foliated. So foliated metamorphic rocks will always apply their characteristics with consistent, regular texture. The question arises that why we don't classify metamorphic rock based on composition. So answer is, there can be more than one existing rock that can metamorphize as same type of rock. More than one different. Gneiss is essentially formed by metamorphism of granite, but it can also form by metamorphism of mudstone. Why I don't classify igneous rocks based on its composition? Because metamorphic rock can have variable composition to it, may have similar texture. And what is the reason the composition variations are not standard? Because any of the existing different types of existing rocks can actually combine to make same type of metamorphic rock. So metamorphic rocks, the rocks that have got metamorphized, Ncert, dynamic and thermal metamorphism, is basically related to the classification on its texture, foliated and non-foliated. The last thing that is mentioned in this chapter of our Ncert is rock cycle, and if I have to take anything about rock cycle with specification, I'll say rock cycle is consistent transition of the different rock types from one to the other. So I can see sedimentary rocks under heat and pressure can become metamorphic. Igneous rock under heat and pressure can become metamorphic rock. Igneous rock when is subjected to weathering, or metamorphic rock when is subjected to weathering, it will generate sedimentary rock. When sedimentary rock and metamorphic rock are subjected to the burial or internal heat, they will convert into magma and will facilitate igneous rock. So if I have to arrange them in a very defined kind of a cycle, what I'll say, that the genesis of magma, solidification of magma creates igneous. So if metamorphic rock, or for that matter sedimentary rock, is subjected to melting and creation of magma, then automatically I'll be developing igneous rock in my next go. If I take the characteristics that is correlated with formation process of sedimentary rock, so whether it is igneous rock that is subjected to weathering or it is metamorphic rock that is subjected to weathering, will result into development of sedimentary rock. And in the similar sequence, if I have to say rock cycle involving metamorphic rock, then I'll say whether it is igneous rock or it is sedimentary rock that is subjected to the dynamic or thermal metamorphism, they will be subjected to the development of metamorphic rock. So basically what I need to understand is that rock cycle projects that dynamic characteristics of surface features forming rocks or material. We have to take it like this. And if you try to combine all of them, I very readily come across the point which says that we can demarcate the development of rock cycle absolutely correlated with dynamism of epigene and hypogene processes. I hope with this you are more comfortable with one of the very elementary topics of our physical geography syllabus, largely hidden. This is the topic that we don't give emphasis to. And if you try to see the questions that comes up from this particular topic, it's basically quite simple one. Factual they are, agreed, but they are simple one, as in I'm aware of it and I can easily get score of the question that is coming up from here. With this approach, if you'll just try to reread, do make sure that you are rereading this chapter number 5 of your Physical Principles of Geography 11th Standard. I think it will now not take more than maximum 15 minutes for you to do justice with this chapter, which is surely having the potentiality of a question or two in your question paper. All the very best to all of you.